Hi everyone! In this video, I'm going to show you how to solve linear inequality word problems. Now, word problems basically involve two completely separate skills. And the second skill usually students are pretty solid on, which is actually solving the equation once they've found it. And that's the skill building that we focus on most in class. It's actually the first part, coming up with the equation in the first place, that's the hard part of word problems, and that's called modeling. So I've got two examples here where we're going to go through and model the inequalities we need to solve these various problems. And I've chosen ones where there's actually two inequalities we're going to set up. It's called a system of inequalities. And then we're going to solve this system of inequalities to find a possible range of solutions. And that's sort of the big difference between inequalities and regular equations. With regular equations, your values are equal to a number. And generally, your solutions can only be usually only one possible solution. With inequalities, though, you get a whole possible range of solutions, right? Greater than this, less than that, and so on. So let's jump into our first problem. An ice cream stand is selling ice cream for $5 each and rocket popsicles for $2.50 each. You are a camp counselor and you have 7 hungry kids who want a treat, and you have $30. Thankfully, and this is good for you, only 2 of them want ice cream, which is good because ice cream is expensive and the popsicles are cheap. That's a good sales pitch you did, by the way, trying to get them to get the multicolored rockets. Good job. So what's the maximum number of ice cream cones you can buy? And the reason you care is because you and your friends get the extras. Okay, so let's set this up. First of all, let's choose what our variables are going to be. I'm going to choose C to be ice cream, so number of ice cream, and R to be number of rockets. Okay, so we have 2 different restrictions that we need to work with. You've got 7 hungry kids. So, if the money runs out, at least the kids will have their treats. So your number of ice cream cones plus your number of rockets has to be at least 7. And the way we say at least 7 is greater or equal to. And then we're going to get a second equation for money. So you have $30 to spend. So the right-hand side, like how much you can spend, has to be less than or equal to 30. But what's your left-hand side going to be? Like, how are you going to get to this less than or equal to 30 number? You're going to do it based on your number of rockets you sell, or you buy for $2.50 each, and your number of ice cream cones you buy for $5 each. So 5 times your number of ice cream plus $2.50 times your number of rockets has to be less than, right? Less than or equal to the amount of money that you have. Okay, so you've got this $30, you've got your 7 items, and you also know that only 2 of the kids want ice cream. Now, this is sort of tricky because we don't actually care about the 2 who want ice cream. What we care about is we care about the ones who want rockets. And the reason is because we care about the maximum number of ice cream you can buy. So the ice cream is going to be at least 2. So we know that C is going to be at least 2. Okay, but we also know that there are 7 hungry kids. So let's actually set up an equation for our 7 hungry kids, right? So we've got our 7 kids. I don't know if we need really an equation for this. Our 7 kids is going to be 2 ice cream. And by the power of subtraction, how many want rockets? 5. Now, the reason we're using 5 instead of 2, so that implies 5 rockets, is because the number of rockets then isn't going to change, right? None of the counselors want rockets because they know better. Rockets are actually disgusting. It's just sugar and water. They aren't really good at all. Ice cream, though, is delicious, so that's obviously what you want. So, sorry, no judgment, and apologies to anyone who can't have lactose or whatever, but I guess my biases are coming out. So we're going to set that rockets equals 5. And this allows us to simplify both of these equations right away. We can do this substitution. We've got 5 rockets over here, and we're going to substitute 5 over here in this equation. And otherwise, our equations are going to be the same. So C plus R is greater than or equal to 7. And our other equation is 5C plus 250 times our number 5 is less than or equal to 30. Okay, and now we just solve these the usual way. So on this equation here, we're going to subtract 5. So we're going to get that C is greater than or equal to 2. Okay, that's good. We can get at least the 2 ice cream we need for the kids. And on this side, we're going to get 5C plus 250 times 5 is 1250. And if you take 1250 away from 30, right, so we're subtracting here, minus 1250, minus 1250. We have our 5 cones, $5 times our number of cones, $5 times our number of cones is has to be less than or equal to $17.50. Okay, so now we're going to divide both sides by 5, divide by 5, divide by 5. And we get that, I'm not even going to use a calculator because I really don't care. C is less than, I don't care about the exact value. All that I care is that it's 3 point something. Right? It doesn't really matter beyond that. How many times does 5 fit into 17? 3 times evenly, and beyond that doesn't matter. Although I know some of you guys are going to be, what is the actual number? Well, the actual number is 3.5. But all that I really care about is the integer part, because you can't actually buy half of an ice cream cone. Or at least no ice cream stand I've ever been to lets you buy half of an ice cream cone. So unfortunately, when you put these two things together, what do you get? You have two different restrictions. And the 0.5 doesn't even count because you can't even buy a 0.5. So C needs to be greater than or equal to 2. It also has to be less than or equal to 3. So guess what? Your number line looks pretty simple. Your number line looks like this. Here's 2. Here's 3. You can have greater than or equal to this number, so solid dot. You can have less than or equal to this number, so solid dot. And that's your total solution. So you're probably going to buy 3 ice creams. So you can buy 3 ice cream. And if you work out the math on that, the kids get 2 of them. You've got 1 cone for yourself. Well, I mean, free food at work. Can't complain that much. All right, so that's one example of a 2 linear inequality question. Let's try one more. Jane is in a high-pressure sales job. She sells phone protection plans for $450 and phone care solutions for $100. I think that's fancy for a screen protector in a case. Actually, you know what? I was at the mall the other day and they had these like paint-on phone cases. I feel like that's crazy though. Paint-on phone protectors. Like, why don't you just get like a glass thing and just slide it on like everybody else for like $5? Anyway, so she's selling these overpriced products, and every week she only has time to complete at most 24 sales. And she must hit a weekly minimum of $4,500 in sales. And that seems like a lot of money, but actually if you think about how much it costs to like rent a space in a mall and like hire someone to work there, that's actually pretty reasonable. Otherwise they're not going to stay in business. If this week she's only sold 5 phone protection plans, determine all possible values for the number of phone care solutions she could sell and still meet her quota. Okay, so let's go through. So there's a bunch of information here. So let's start with our variables. So let's do protection plans. Let's do P. So P is number of protection plans. I think that's like an extended warranty. And phone care solutions, let's make that C, is number of care solutions. Okay, so one thing we have here is that she can do at most 24 sales. So at most means less than or equal to 24. And her sales are either going to be protection plans or they are going to be phone care solutions. So that's P plus C. Now we also have all this money business. So the phone protection plans are $450 and the phone care solutions are $100. And they have to total $4,500. Minimum. Okay, so minimum means greater than or equal to. So greater than or equal to $4,500, and that has to come from $450 times her number of phone protection plans, plus $100 for her phone care solutions. Right? So this equation just says that each care solution, she multiplies by $100. Each phone protection plan, she multiplies by $450. And you add those up, it's got to be greater than or equal to $4,500. And then we're just told in this case, she's sold 5. Okay, that's just a number we can use. She has sold 5 phone protection plans. Okay, So P equals 5. So we're going to substitute 5 over here, and we're going to substitute 5 over here. Is this looking familiar? Kind of the same thing we did in the last problem, right? So this plus C is less than or equal to 24. So then C, when you subtract 5, is less than or equal to 19. Okay, cool. Not so bad. On this side, we've got 450 times that 5 plus 100. C is greater than or equal to 4,500. Okay. So let's go through. 5 times 450. Let's see. So 4 of those would be 1,800. So 5 of them will be 2,250. Mental math trick I did there, by the way, was doubling 450 twice was easy. Doubling is 900. Doubling again is 1,800. And then 1,800 plus 450 plus 100C greater than or equal to 4,500. And 2,250 is half of 4,500. So when we subtract, it's going to be just greater than or equal to 2,250. And dividing by 100 I can do in my head. That's not too difficult. You just shift your decimal place 2 times. So that's 22.5. Wait a second. What's wrong with these two inequalities? Can C be less than 19 and also be greater than 22.5? No. That means, unfortunately, Jane is hooped. Jane can't sell enough, whatever C was, care solutions to meet her quota. Sorry, Jane.